Good morning, students. Welcome back to the online classes in physics for standard 12th. Today we shall discuss one important topic, Van de Graaff generator. I am more interested in discussing its principle. So we are at the verge of concluding this particular chapter. So whatever we have read so far, based on that, this is a practical device. It's basically an application for whatever you have read so far. This name generator, what does it generate? It generates, we say, charges. So it is a machine that can build up high voltages. It builds up high potentials or high voltages. Now how high, that will depend upon the machine itself, but it can be as high as few millions volt. Few millions of volts. Very high potentials, voltages can be created by using this particular generator. So today we will discuss what is its basic principle. Before discussing the generator, you know, students, if there is a cell, conducting cell, so this is what? This is a conducting cell of radius capital R. Suppose charge Q has been distributed uniformly on its surface. Since it's conductor, you know, within the bulk, and this is like a cavity, inside also the electric field is how much? 0. This we have read. And for points outside, the electric field is as if the charge is present where? At the center. So for points outside, the electric field is given by the formula 1 by 4 pi epsilon naught. That charge on the cell, we will assume it to be at the center, and from center whatever distance is there for the point, say it be R, so Q upon R square. Since electric field is 0 inside, we know E is equal to minus dV by dr, so that also becomes 0. And if dV by dr becomes 0, that means potential becomes constant for all points inside this cell and has the same value as the value of potential on the surface, which is how much? 1 upon 4 pi epsilon naught Q upon capital R. So if I take a point here, if I take a point here, or I take a point on the surface, at all these 3 points, the potential will be same. How much will it be? 1 by 4 pi epsilon naught Q by R. Is it clear, students? But for points outside, for example, at this point is outside the cell, so the entire charge you will assume to be at the center. At this point, the potential will be how much? V is equal to 1 by 4 pi epsilon naught times Q upon small r, where small r is the distance of this point from the center. But at any point inside, the potential will be given by this formula. With this idea in mind, suppose by some means, somehow, we manage to insert a small spherical charged body inside this cell. Let its radius be small r. Its radius we take as small r. This radius is capital R. And on this, there is some charge, suppose Q. Now this inside body need not be a cell. It may be a cell, it may be a solid conducting sphere, does not matter. Charge on it is small q, and we for the time being assume this is small q to be positive. Now let's see the potentials at 2 important points. You see the total potential at R. What is R? R is, this point is, your R is equal to 0, the center of the cell or the sphere, and this radius we have taken R. So on the surface of this small sphere, we wish to find the potential. Now the potential at this point is due to two things. First, due to the cell itself, and second, due to the small sphere. So potential at R is equal to potential due to sphere plus potential due to cell. At which point? At R. At R. Now potential due to this sphere on its surface, you know students, what is the formula? 1 by 4 pi epsilon naught charge on it, that is Q upon small r. This small r is the radius. Earlier I had written here r, suppose I take it as r dash, then this becomes r dash, this becomes r dash. I should choose different symbols. Then potential at the same point due to the cell, I have discussed, due to the cell for all points inside, the potential has the same value as the potential on the surface, that is this much. So it becomes 1 by 4 pi epsilon naught times capital Q upon capital R. Is it clear? So this is the net potential at any point on the surface of the smaller sphere which is present at the center of the cell. Now we choose another point on the surface of the cell. Suppose this point, or if you wish, you can take a point over here or here or here, anywhere. Potential on the surface is also due to two things, due to the sphere at the center and due to the cell itself. Due to the sphere, at this point, the potential is as if the total charge will be present at its center. What is the charge on this body? Small q. So that you imagine at the center, and from that, this point is at how much distance? Capital R. So the formula will be 1 by 4 pi epsilon naught small q upon capital R plus potential due to this cell. So due to cell on its surface, formula, it's easy one, 1 by 4 pi epsilon naught capital Q by capital R. Please pause for a moment. Observe carefully each of the four terms which I have written. Here we are finding potential at this point, but I have written capital R because it is the potential at this point due to the cell. And due to the cell, since electric field is 0 inside, now electric field is not 0 inside because we have put charge. This potential must be constant and has the same value as on the surface. That's why this will not be small r, it will be capital R. Okay. Having got the values of these two, let's calculate what is their difference. Basically what we have written here is the potential difference between the 2 points, one on the surface of the small sphere at the center and other point on the spherical cell. How much will it be? So this becomes equal to this minus this. Now if you see, when you subtract these two terms will cancel. And what will be left? We can take 1 by 4 pi epsilon naught common. We can take q also common. So this minus this. So what will be left is 1 by r minus 1 by capital R. Now this small r, students, is less than capital R. It is clear in the figure. This implies 1 by small r is greater than 1 by capital R. If this is greater than this difference must be greater than 0. So VR minus V capital R is greater than 0. That means this difference is positive. This is possible only if we are subtracting a smaller number from bigger number. That means potential at small r must be greater than potential at capital R. Is it clear, students? This is very important. This means whatever be the value of capital Q, even if capital Q, the charge on the cell, is very large, even if it is very large, we always have potential at small r to be greater than potential at capital R. And this means that if we connect these two by a connecting wire, this is a conductor. Any conducting wire, if we use to connect these two, the sphere at the center and the cell, now the inner one is at higher potential and this is at lower potential. If we connect them, so if suppose I call it as A and this cell I call it as B, if A and B are connected, how? By means of a conducting wire, then charge which we have taken as positive will flow, from higher potential to lower potential. So the inner one is at higher potential, we have seen. So from A to B, I should write from the inner to the outer sphere. Let me repeat what I told. Whatever be the value of this charge, capital Q, irrespective of that, if these two are connected, charge will always flow from the inner sphere to the outer sphere, provided the inner sphere has positive charge. If it is negatively charged, then the opposite thing will happen. What does this mean? Somehow, suppose this charge Q will get transferred to this, it will lose the charge. Somehow, if we manage to charge it again by some means, we will discuss it afterwards. If we charge it again you connect with a wire, again this charge will flow from A to B, again this will get neutralized, again you charge it. So in steps like this, continuously, if we have a connecting wire between these two, and continuously if you are able to supply some charge to the inner sphere, then from the inner sphere the charge would flow to the outer sphere and it will accumulate on this outer sphere. So the outer sphere will develop large amount of charge. Now the potential due to this sphere on its surface we have discussed, that is how much? 1 by 4 pi epsilon naught Q upon capital R. As this charge capital Q increases to a large value, the potential also increases to a very large value. So does it mean we will be able to accumulate infinite amount of charge, or we will be able to create infinite potential on the surface? No. Why no? Because the surrounding material is air. If it is vacuum, to some extent it is possible, yes, but generally we have a setup, and around that setup there will be some material. Even if there is nothing, there will be air. Air naturally it is a very good insulator, but if the electric field increases to a large value, if the potential increases to a very large value after accumulation of large amount of charge, then there is a possibility of discharge. Large value of charge means the electric field in this region, in the vicinity of this particular sphere, will be very large. That electric field, if it crosses the breakdown limit of air, then discharge will take place. The breakdown field of air is about 3 into 10 to the power 6 volts per meter. This is the value of electric field. E breakdown, I am writing BD for breakdown. For air it is approximately 3 into 10 to the power 6 volts per meter. If this charge goes on accumulating, there will be one situation where it creates a potential, or it creates an electric field which reaches this value. Under that circumstance, the air loses its insulating property. That means through air you will have flow of charges. These charges cannot stay as such, they will flow through the air, and that we call as discharge. So electric discharge will take place. What you will see is a spark. The discharge will be resulting in a spark, just as you see in case of thunder. So there also basically it is discharge between the cloud and the earth, or between one cloud and other cloud. That is because the air breakdown limit has been exceeded due to the intense electric field between two clouds, or between cloud and earth. So this is the basic principle how we can generate more amount of charge on a spherical cell. So this is the basic principle of Van de Graaff generator. I would suggest you to write it properly in your note. You can consult your textbook also. Let's see about its construction. So you can see the schematic representation for a Van de Graaff generator. Here there will be a motor. These two circular parts, they are pulleys. These two pulleys are connected by a belt, insulating belt, that keeps on turning like this, rotating like this. The bottom pulley, the belt over there, that is sprayed with some positive charge. So this arrow mark, it represents a metal brush which gives some charge from the source. So we assume it delivers positive charge. A positive charge is sprayed on that. That positive charge which is sprayed on the belt, because the belt is turning, this belt after some time would arrive here. That positive charge would then, through this brush, would move to the outer cell. Why it would move? We have already discussed the potential of the inner sphere is always greater compared to the potential of the outer cell. Because of this, this positive charge which has been sprayed here would, after moving to the top, flow from the inner sphere to the outer sphere, and this outer cell will develop positive charge. So this process continues, more and more charges. As long as you keep on spraying the charges, those charges will go up and will then flow through this metal brush to this cell. This charge initially goes on accumulating to a very large value till its potential becomes so large that its electric field crosses or approaches the breakdown limit of air. And if it approaches the breakdown limit, which is approximately 3 into 10 to the power 6 volts per meter, then it cannot store further amount of charge. If you try to charge more, it will not store, because after this electric field has been attained, these charges would flow even through air in the form of spark that we call as discharge. Is it clear, students? Now I would like to show this particular arrangement of Van de Graaff generator to you. So let's see that. Now you can see the schematic representation of this Van de Graaff generator. It is similar to this particular arrangement. You can see this is the motor. This blue colored part, inside this box there is a motor that can be driven using electricity. At the top you can see there is a roller, and a similar roller or pulley like arrangement is there. This is a roller. In fact, there is a roller at the bottom also. There are two rollers and there is a belt between these two rollers. Now we will not spray charges from this using some metal brush sprayer. Rather, what is done here, you can see the bottom roller is actually metallic. It has a metallic covering, and upper one is insulator. When it rubs against this roller, there is polarization in the insulator that takes place, and that induces charge, because of which this material, the belt material, insulating material, gets charged. Here basically it is being charged by rubbing. Do you remember frictional electricity? So whatever be the way, whether it is frictional electricity or whether we spray charge, our point of concern is that we should supply some charge to the belt. So here it gets charged, and then at the top there is a metallic arrangement. This charge from the belt gets transferred to this metallic arrangement, over which we put a dome. You can see this is a metallic dome like structure. It's not possible to have a complete sphere. Technically that should be the best thing, but if it is complete sphere, we can't insert the small sphere within that. So it has a gap, so it is put like this. Yes, now it is fitted. So our Van de Graaff generator is ready. So basically from that inner part, the charge will be transferred to this particular dome. So let him put it on. You can see this belt is now turning. As the belt turns, it keeps on piling charge onto this particular dome. If you remember, students, earlier also I had told such setups would work better in dry weather. Unfortunately nowadays it's raining over here, but even then it will get some charge. So let's wait for some time. You could see how it got attracted, and I also felt a bit of shock This was not a very good thing to do, but just I want to show you. This is a metallic foil. This is a metal foil, and I am holding not the foil, I am holding the tape, that is insulator. And if I try to bring it close, you see how it gets attracted by the process of induction. Could you see it is making some angle? Why does it get attracted? This dome is now charged. This is metal. Suppose it is positively charged, so electrons will move from this part, this side of the plane to the opposite side. So this metal foil, the electrons will flow. If they flow from this side to this side will be negatively charged, this side will become positively charged. Now that is positive. So positive and negative, there will be attraction. Positive and positive, there will be repulsion also. But the negative charges are closer to that particular dome. That's why there is a net force of attraction. Yes, can you see? And if I touch it, it will repel also, because the charges will redistribute themselves. This clearly indicates that it is charged. And if I go too close, it will discharge also. There might be a spark. Now I think I can take the risk. Yes. Now there is no attraction, there will be repulsion in fact. Because this, on touching that, it will transfer its charge. So if you keep for some time, then you will not find any appreciable attraction. Let me charge it again. So, okay, this you have seen. And I have demonstrated many other things from this Van de Graaff generator also. So I am very much sure you remember those things. Let me see if you could see some spark. I have told you, as this process continues, charge keeps on piling over that particular dome. And if it is good weather, good means dry weather, it will reach to several thousands of volts, if not millions, several thousands of volts of potential will be generated by this particular generator also. I have another metallic structure. And let's see if you could hear or you could see some spark. Yes, I think that was quite a clear sound. This part has been connected to through a wire to the earthing. So whatever excess charge was there, now it has flown through this particular wire to the earth. Now it is safe to touch. See, I can touch it quite easily. So that is the only precaution that we should use. Without earthing this, we should not touch it. Otherwise you may get a fatal shock. Okay students, that was the working of a Van de Graaff generator. Hope you understood it properly. So we have finished students this particular chapter. Next class I will discuss some of the questions from the NCERT textbook, exercise questions. Now, before I leave, I would like to discuss one example from your NCERT based on capacitors. So this is the situation number is, this is example 2.10. I would like you to take out your books and see that particular example and read the question first. I am reading the question for you. It has bit A, which says a 900 picofarad capacitor is charged by 100 volt battery. How much electrostatic energy is stored by the capacitor? So we have to find electrostatic energy. So electrostatic energy U is given by any of these three formula, half QV or half CV square or Q square upon 2C. Now here V is given and C is given. C is given in picofarad. Pico means you have to multiply by 10 to the power minus 12. So this becomes 900 into 10 to the power minus 12 farad. If you know C and V, put the values of C and V here and calculate the answer. So use this particular formula, you will get the answer as 4.5 times 10 to the power minus 6 joules. You can also use this particular formula, but for this, using this formula, you have to first find Q. If you calculate Q, Q will be C times V. C into V, you can calculate from here, that becomes 900 into 10 to the power minus 12 into 100. So 9 into 10 to the power 2 and 2 4, 4 and minus 12 becomes minus 8 coulomb. So 9 times 10 to the power minus 8 coulomb, that is the charge on this particular capacitor. And then you will use the formula E is equal to Q square by 2C, or you can also use half QV. So you will get the answer as this 4.5 10 to the power minus 6 joules. Either you do this way or you do this way for bit A. Now it has second part which says like so, that the capacitor is disconnected from the battery. From this battery it is disconnected and then connected to another identical 900 picofarad capacitor. This capacitor, after it is disconnected from the battery, it is connected to another identical capacitor. Both have same capacitance, 900 picofarad. Now the question is asked, what is the electrostatic energy stored by the system of these two capacitors? So total energy is energy in this capacitor plus energy in this capacitor. If we have done by this method, you have calculated Q. Now when you connect it to an identical capacitor, these two plates will come at same potential. These two plates will also come at same potential. The potential difference between the plates was how much? 100 volt. Here also the potential difference between the two plates will be how much? 100 volt, because they are connected in parallel, you can say. These two plates are at same potential, these two plates are also at same potential. So 100 volt will be the potential difference. Now what about the charge? Suppose the charge here, initially it was Q and minus Q. So on one of the plate it was Q. That same charge Q has now been distributed on these two plates. And it will be distributed equally because they are identical capacitors, they are at same potential. It means charge on both the plates now will be how much? Q by 2 and Q by 2. Likewise, this will be minus Q upon 2 and minus Q upon 2. Initially, the charge on the capacitor was Q, which we have calculated. Because it is connected to an identical capacitor, charge on one of the plate now will distribute between two. Earlier, entire charge Q was on one plate. Now that entire charge Q has to be on two plates. Total charge is same, you can see. Q by 2 and Q by 2 will become how much? Q. Minus Q by 2 and minus Q by 2 will become how much? Minus Q. So this is the concept. Now total energy is energy on one capacitor plus energy on other capacitor. But both the capacitors are identical. On both of them charges are same. And on both of them the potential difference is also same. So both of them will have same potential energy. So for 2 into, I can write electrostatic energy in each capacitor is equal to 2 into. Now energy for one capacitor is formula is Q square upon 2C, but instead of Q it is Q by 2. So Q by 2 square upon 2C. Am I clear to you students? I discussed both the energies must be same, so it is twice of energy on one of the capacitor. Energy on one of the capacitor will be Q by 2 square by twice of its capacitance. Now if you see this 2 to, oh, I will not cancel it. This becomes Q square by 4. Q square by 4. That 4 and this 2. This by 4 and this is 2. It becomes half. Half of Q square by 2C. Q square by 2C have already calculated, students. That was the energy in the first case. That was how much? 4.5 10 to the power minus 6. So half of that. So half into that much. So answer will be half of this means 2.25 10 to the power minus 6 joules will be the energy. Now what do we observe? We observe that the total energy has decreased or increased. What do you think? It was 4.5, now it's half of 4.5. So clearly it has decreased. Where did the energy go? This energy, we say, students, is lost as a heat and electromagnetic radiation. What happens when you connect this to the second capacitor? Momentarily, for some time, there is some flow of charge, and when charge flows, there is some current, and that current through these wires result in heat. Heating effect of current, you have read students in the standard 10th, Joule's law of heating. So because of that, there is always some loss of energy. In fact, 50% of the energy has been lost. Only half of the initial energy has been there. If part C, they would have asked lost energy or energy loss. So energy lost will be its initial energy minus its final energy. That we will find as how much? 2.25 into 10 to the power minus 6 joules. 4.5 minus 2.25, that will be 2.25 10 to the power minus 6 joules. Okay students, I will stop here. Come prepared in the next class for, if possible, try to do the exercise questions from NCERT. So take it as a homework for today. So your homework will be exercise questions. Try yourself. I will discuss in the next class some of the questions from NCERT, including additional exercises. Clear? Try to do as many as possible. In the next class, I will discuss them. So till then, goodbye students. Take care. Read well. Thank you.